Okay, maybe this will be the last video. I think we have like 7 or 8 problems left. So let's see what we have here. Okay, we are ready now. We're going to look at the derivative of the natural log functions. So this is problem number 70. I'll write it down. We'll quickly review. F of x equals 5 natural log of x. And we want to find the derivative. Derivative of the natural log function is very straightforward. Of course, the 5 tags along. You take whatever is inside the natural log, and it simply goes down the bottom, and then you multiply by the derivative of the natural log. So in this case, we just have 5 over x. So this one we can really probably just do right here. So once again, well, maybe not. I could do it, but just in case someone has some questions. So f of x equals natural log of 5x. Once again, what the derivative is, you take 1 over everything inside the natural log, and then you multiply by the derivative of what's inside the natural log. So it's a 2-step process. In this case, the 5's cancel out. The answer should be 1 over x. Here, looks like it's going to be a product rule problem because I have x to the 4th times natural log of 3x. So it's like we have 2 functions multiplied. Take a look at this one. So using the product rule, the first times the derivative of the second. Derivative of natural log of 3x is 1 over 3x. Then you multiply by the derivative of what's inside the natural log, which is 3. So that's the first half of the product rule. That's the first times the derivative of the second, plus the second times the derivative of the first, which is 4x cubed. So these 3's cancel out. X to the 4th over x is x to the 3rd. Now someone may want to factor out the x cubed. Don't really think you need to, probably. Hopefully WebAssigned would take either answer. Maybe I'll just put in the parenthesis answer. So here's another one that's probably going to have to use the quotient rule. Y equals natural log of x over x cubed. So if I use the quotient rule to take the derivative low d high, derivative of the high is just going to be 1 over x minus high, high, natural log of x, d low, 3x squared, all over the low squared. So this is going to be x squared minus 3x squared times natural log of x over x to the 6th. Now I can cancel out an x squared because I have x squared in all three of these terms. 1 minus 3 natural log of x for x to the 4th. All right, let's see if that's correct. So now we have this one. Maybe I can just do, because derivative of this natural log is 1 over everything inside the natural log times the derivative of this. I think I can do that right here. So 1 over 8x squared minus 7x plus 3, then times the derivative of what's inside the natural log, which would be 16x minus 7. This one is going to be like, I believe you have to use the chain rule. It says, hint, use the extended pair rule. Is that what they call the chain rule? I don't even know. Anyways, so once again, you bring the 12 down front, and then you simply copy the parentheses and subtract 1 from the exponent. So that's like the outside. And then the inside is you take the derivative of what's inside the parentheses. Well, the derivative of natural log of x is just 1 over x. So basically, I have x in the bottom here. All right, 2 problems left. I think they're 2-story problems. And then we're done with these review problems. Suppose that a company introduces a new computer game in a city using television advertisements. Surveys show that P% of the target audience buy the game after X ads are broadcast, satisfying the equation below. Complete parts A through D. So here's a story problem where, so a company is trying to sell a computer game, and they put up some ads on TV, and they supposedly have this equation that predicts the percent the percentage of people that will buy the game based upon how many ads they run. So X is the number of ads they run, and P is going to be the percent of the people that end up buying the game. So the first question is, what percentage buy the game without seeing a TV ad? So what you do is you have this equation, and we're going to plug in, and they even tell you here, you plug in 0 for X. So let's just go ahead and do this. This first part's pretty simple. I assume it's going to get more complicated. So this is 76. So this equation, P of X equals 100 over 1 plus 50 e to the negative 0.11x. So part A says if they don't run any ads, what percent of the people are going to buy the game? So you put in 0 for X. E to the 0, which is just 1. So you have 100 over 1 plus 50. So this, oh, you can't see what I'm doing, sorry. Here's the equation. We're trying to figure out what percent of the people will buy the game with no TV ads run. So the point is, some people will still buy the game, even though they don't run TV ads, but they want to know how many would actually end up buying the game, even if we didn't run any TV ads. And that percent is 100 over 51. And they say round to the nearest tenth. So it's 1.961. To the nearest tenth is actually 2%, because this 9 bumps up to a 0. So actually 2% of people are going to buy the game if they don't do any advertising. Now they say, what percentage buy the game after the ad runs 26 times? So now we go plug in 26 for X and see what happens. So part B is P of 26. So you have 100 over 1 plus 50 e to the negative 0.11 times 26. Definitely have to get out my calculator. Going to figure out this exponential first. So negative 0.11 times 26 equals, now I want to take e to that and multiply that times 50. Then add 1 to that, and that goes in the bottom of the denominator times 100. Looks like 25.9. So it looks like when they run the ad 26 times, they're up to a little over a fourth of the people buying the game. So 25.9. Find the rate of change. So now remember I said a few problems ago, rate of change means derivative So derivative of this. Now this is going to be quotient rule. We'll see how messy it gets. So low d high, derivative of 100 is just 0. Minus high d low. If you look at the derivative, the denominator derivative of 1 is 0. For this one, 50, you copy down the exponential function, then you multiply by the derivative of the exponent. So this is low d high minus high d low over the low squared. Wow. Sort of messy. This whole thing is 0. Here I've got negative 100 times 50 times negative 0.11. So it's going to be positive. So 100 times 0.11 is 11. 11 times 50, I believe, is 550. So I've got 550 e to the negative 0.11x over 1 plus 50 e to negative 0.11x. That whole thing squared. Very messy, but there's no way to simplify it. See how we can type this in. So let's type in the top 550 e to the negative 0.11x divided by parentheses 1 plus 50 e to the negative 0.11x. And that whole thing squared. All right, that's a relief. Sketch graph of the function, choose the correct graph below. So multiple choice. So now we're looking at the sketch of the function, not the derivative function. When I do things like this, especially if I have 4 choices, I just try and eliminate. In other words, we know we already calculated when x is 0, p is 2%. So you look at each of these and you see which one, for instance, if you look at this one, x is 0 is right here. The graph is not even touching, it doesn't exist. That cannot be correct. If I look at B, when x is 0, p is supposed to be 2, p's up here almost at 100. That can't be correct. I look at C, when x is 0, p is 2, that looks reasonable. So that one could be correct. And then the last one, when x is 0, it doesn't exist. Pretty simple. I just look at one value and it's obvious which one is correct. All right, the last problem. Looks like another story problem. Pharmaceutical firms invest significant money in testing any new medication. After the drug is approved for use, it still takes time for physicians to fully accept and start prescribing the medication. The acceptance by physicians approaches a limiting value of 100% or 1 after time t in months. Suppose that the percentage p of physicians prescribing new cancer medication is approximated by the equation below. Complete parts A through C. So here it's saying P is the percent of physicians who will prescribe or recommend a medication, and T is the number of months. So the idea is the more that time passes, more physicians will become comfortable and begin to prescribe the medication. So that's what that equation, let me write down this equation, and then we'll start looking at answering these questions. So P of T equals 100, 1 minus e to the negative 0.42 t. First question, what percent of doctors are prescribing the medication after 12 months? So basically for part A, I'll show you in a minute, we're going to be looking at P of 12. Right, so here's this equation. P is the percentage of doctors that prescribe it. T is the number of months that have passed. So they're saying, where are we at after 12 months? How many doctors will prescribe it? What percent? So you simply plug in 12 for T. You grab your calculator. Going to first look at the exponent, negative 0.42 times 12. And that becomes the exponent of the natural exponential. You add that to 1, multiply by 100, 99.35. So basically it's saying after a year, almost all the doctors are prescribing it, 99%, over 99%. So it says round to the nearest tenth. So I think I'm gonna go with 99.4. Now find the derivative of P of 12. So that means now we're going to look at the rate of change, how the percentage of doctors are changing with respect to time. And we're going to see after 12 months. Now, what's my hunch? My hunch is after 12 months, we've seen most of the doctors are already using it. So I think that the change is going to be very small. There's not much change going on. They're already all using it, but we're going to find out. So part B, we want first derivative and see what it is at 12 months. So I've got to take the first derivative. Now in this case, let's go ahead and multiply out this parenthesis. If I do that, it's 100 minus 100 e to the minus 0.42 t. So the first derivative is the 100 tags along. You copy down the exponential. Then you multiply by the derivative of the exponential. So this looks like that should be the derivative. Now if you plug in 12, do this calculation. So negative 0.42 times 12 e to the x, that whole thing times negative 42. I get negative 0.272. So the growth rate is decreasing, which makes sense because by this point, almost all the doctors have already made the change. Let's see. Round to the nearest tenth. So I have negative 0.3. Up. All right. So here's what happens when you get the incorrect answer. You go back and check your work. Let's make sure I did the correct derivative correctly. So I decided to multiply it out here. And then, I think it's maybe a minus sign, because when I took the first root of this, I think I should have a minus here, which means this should be positive. Let's see if it's positive 0.3. So once again, signs usually get you. Yep, that was it. Interpretation below. Basically what it's saying is after 12 months, the growth rate is 0.3%, pretty small growth rate. Increasing by 3% per month. That looks correct. That's B's not correct. C, it's not decreasing, it's increasing. Oh, here's another graph. Well, and this is the graph of the percent. So we know, first of all, at 0, it's got to be 100. So it's got to be A, B, or C. And we looked at 12, and 12 was like 99. So let's look at which one of these has 12 when T is 12. The percentage is like 99. Well, this is low here, so that's definitely not correct. Here it's actually when it starts, it should start at 100. That's not correct. I would say this one looks like it has the chance of being correct. Although actually, I think I may have misspoken. When the time is 0, I think I may have misspoken. When the time is 0, e to the 0 is 1. 1 minus 1 is 0. The percent is 0. So actually, all three of these are wrong. It has to be this one. Sorry about that. I confused myself. All right, so that's it. That's all 77 problems. Hopefully that'll help you as you prepare for the exam.